Hello, everybody. A very interesting lesson, I believe. In a controlled experiment, I can determine if a treatment is effective by determining if the mean difference, the difference in the means from the treatment group with the control group, is outside the confidence interval, the range of expected values due to random chance. If I perform a controlled experiment, I don't want my output to be a value that would be obtained due to random chance. I want my output to be awesome. I want my mean difference to be outside the confidence interval. I don't want to be an expected value. So let me just pause it for one moment. The first step is to find the mean difference in determining if a treatment is effective. Joseph was curious to determine if scent improves memory. A test was created where better memory is indicated by higher test scores. A controlled experiment was performed where one group was given the test on scented paper and the other group was given the test on unscented paper. The summary statistics from the experiment are given below. The first thing I need to do is find the difference of the means. I need to see how much better the treatment group did, or the worse the treatment group did than the control group. It even says, calculate the difference in the means, and it even says scented minus unscented. You do need to know that X bar is the mean, SX is the standard deviation. So the difference in the means, 23 minus 18 is 5. The mean difference is 5. This particular question isn't asking for it, but often they'll ask you to explain its meaning in the context of the problem. I have a script for you here. On average, the treatment group scored the mean difference, whatever that value is, higher or lower than the control group. So in this case, on average, students in the centered paper group scored 5 points higher than students in the unscented paper group. Now, just because that group did better, that doesn't mean that the scented paper caused it. If I compare my two classes' scores, they're not going to be exactly the same. One will be higher due to random chance. Just that's the way things work. Things aren't going to be exactly the same. So what I need to determine is this value a value that I would obtain due to random chance? So my mean difference is 5. So now I need to find the range of expected values due to random chance. I need to find the confidence interval. So this is re-randomized. This is the distribution due to random chance. There's no treatment group. There's no control group. So I'm going to find the confidence interval is the mean plus 2 times the standard deviation, and the mean minus 2 times the standard deviation. Wow, that came out really sloppy there. That's like too sloppy for me, and I'm pretty bad. 2 times 1.548. Better. So I'm going to pop that into the calculator. 0.030 plus 2 times 1.548 and minus. And sometimes it'll say to round, and sometimes it won't. In this case, it does say to round to the nearest hundredth. So my confidence interval is negative 3.07 to 3.13. So it's important to understand what I just found. This is the range of expected values due to random chance. If I just took a group of students and I separated them randomly and I took half of their scores and the other half and I found the averages and I subtracted them, the difference in the scores should be between negative 3.07 points, meaning the first group could be 3.07 lower, or the first group could be 3.13 higher due to random chance, not that the treatment did anything. So we look at my value. I don't want to be due to random chance. If I'm going to make millions of dollars on my scented paper idea, I want my group to be way better than everybody else. I don't want to be a value that would be obtained due to random chance. Is 5 an expected value due to random chance? No, it's outside the confidence interval. That's good. I did it. So is it statistically significant? Yes. 5 is outside the confidence interval, or you can say 5 is outside the range. A new computer here. I'm trying to find some space. Forgot how to use this thing. Is outside the range of expected values due to random chance. I like that second sentence better because it just shows more understanding. But if you say yes, it's outside the confidence interval, that's fine. But again, the reason that that's the case is 5 is outside the range of expected values due to random chance. I wouldn't have gotten that big of a value due to random chance. So the reason I got that 5 is the scented paper worked, the treatment worked. Let's take a look at one more quickly. Let's take a look at, so now you always need to find them, you always need to start with the mean difference. They might give you the mean difference, or you might have to find the mean difference by subtracting. So for this example, I had to find the mean difference by subtracting the means, which they gave us. If I take a look at number 5, I'm going to kind of skim it here. It was observed that the mean grade of the students in the class with the interactive whiteboard was 0.6 higher than the class without it. That's the mean difference. The mean difference is 0.6. So if they tell you the difference in the means is, that's the mean difference. You don't have to subtract anything. If they give you the means, then you have to subtract them to find the mean difference. So sometimes you'll have to subtract them, and sometimes it'll just give it to you. So is 0.6 an expected value due to random chance? I find the confidence interval, mean, plus 2 times the standard deviation, mean minus 2 times the standard deviation, 0.01 plus 2 times 0.38, and minus, oops, does it say to round to anything? I'm looking up, and I'm seeing hundredth. Oh my God. Struggling here. All right. So I have negative, oh my God, 0.01 minus 2 times 0.38, negative 0.75, 0.77. So those are to the nearest hundredth already, so they're good. So I have negative 0.75 to 0.77. That's the range of expected values due to random chance. Is the mean difference in the range of expected values due to random chance? Yes. Therefore, I would have gotten that value due to random chance. It didn't work. The treatment was not effective. Is it significant? No. 0.6 is inside the confidence interval, or you can say 0.6 is in the range of expected values due to random chance. If it's in the range of expected values due to random chance, then the treatment didn't do anything. I want to be outside. I want my group to be awesome compared to other groups. In this case, it's not. So find the mean difference. Find the confidence interval, the range of expected values due to random chance. In a controlled experiment, I don't want to be expected. I don't want to be inside. If I am inside, like I am here, then no, it's not significant because it's inside. And if I'm outside, like I was here, 5 is outside the range of expected values, then yes, it was significant. I shouldn't have gotten that due to random chance. I got that because the treatment worked. That's it. Goodbye.